Hey everybody, it's Jenny from Norman S. Wright. Last week I talked about environmental product declarations, and I said that this week I would talk about an alternative to EPDs that we are also seeing. So this week I'm going to talk about the CIBSE TM65. Let's get started.
The Chartered Institution of Building Service Engineers, CIBSE, is an international professional engineering association based in London that represents building service engineers. They developed Technical Memorandum 65, TM65, which is a methodology for calculating the embodied carbon of building equipment, especially when no EPD is available. If you remember a few weeks ago, to decarbonize buildings, we need to understand both the operational carbon, which is the emissions from using the equipment, and the embodied carbon, which includes all the emissions associated with manufacturing, transporting, installing, maintaining, and disposing of the equipment. Let's move this over and make a little more room. TM65 is easier for complicated products like HVAC equipment. Let's look at how it works. It starts with data collection. This is gathering as much information as possible about the product. This includes the weight of the unit, materials used like metals, plastic, refrigerants, and any other relevant details. If you don't have an EPD, you can rely on product specifications and data sheets. Next, we look at material breakdown. The manufacturer would break down the product into its main components. Each material has a different carbon footprint. And next, we apply default factors. TM65 provides a set of default factors that help estimate the embodied carbon for each material. These factors are based on typical values from industry data. By multiplying these factors with the weight of each material, then we can estimate the embodied carbon of that material. Let's move this over again. Next, we sum up the embodied carbon. The sum of the carbon emission for all the materials are totaled to make the sum of the embodied carbon of the product. And then we create the final report. TM65 provides guidance on how to report the results, ensuring transparency and consistency. This report can then be used to compare different HVAC equipment. Let's slide this over again. TM65 defines the stages of life cycle the same as EPDs do. A large proportion of embodied carbon in HVAC products is associated with the product stage. That's A1 through A3. These stages represent over 90% of the embodied carbon. This is due to the fact that the majority of HVAC components are made of metals, electronics, and plastics and have complex supply chains. The product stage includes the carbon emissions associated with extraction, transporting, and processing of materials, and the energy consumption used to manufacture the product. For example, TM65 shows the embodied carbon for some common HVAC equipment raw materials, such as aluminum, which is 13.1 kilograms of CO2 equivalent per kilogram of aluminum. 1 kilogram of CO2 equivalents is equivalent to the effect of 1 kilogram of CO2 emission. So for example, the emission of 1 kilogram of methane is equal to 25 kilograms CO2e. So next there's copper at 3.81 kilograms CO2 equivalent per kilogram of copper. Iron is 2.03, insulation is 1.86, stainless steel is 4.4. Let's move this over again. TM65 has two calculation methods, the basic method and the mid-level method. The basic level requires information only on material content and information on refrigerants if used. And mid-level requires additional information such as energy used in manufacturing and the location of the factory. Which level is used depends on how much information is available. The basic level uses scale-up factors based on the product complexity and generic product assumptions. It doesn't need as much manufacturer information as the mid-level calculation does. The basic calculation sums up each material by weight times their CO2 equivalent factors, then applies a scale-up factor based on product complexity. For instance, low complexity products like ductwork would have a scale-up factor of 1.3, whereas a medium complexity product like pumps would be a 1.4, and high complexity products like air handlers or heat pumps would have a scale-up factor of 1.6. And then if the product has refrigerant, you would add in for refrigerant leakage. The mid-level calculation does all of this, but it also takes into account information that covers other part of the building life cycle. Let's slide over again and look at an example that is in TM65 for a heat pump. So let's say this heat pump weighs 1,000 kilograms. And sorry, TM65 is in metric units, so they use kilograms in this example. So let's label the columns across the top: material, percent by weight, times 1,000 kilograms, CO2 per kilogram, and total. So let's say our heat pump has plastic in it that's 4% by weight, stainless steel is 10% by weight, aluminum is 7%, brass is 1%, steel is 60%, copper is 10%, and electronic components make up 3%. If you multiply that by 1,000 kilograms, you get 40, 170, 10, 600, 100, and 30 kilograms for each of these materials. And then I'll fill in the CO2 per kilogram in TM65 for each of these materials, which is 3.31, 4.4, 13.1, 4.8, 2.97, 3.81, and 49. And if you multiply that across, this is what you get. And if we total that down, we get 5,170.4. Now, if you add up these materials, we have 95% of the material by weight. That is the minimum that you can have to use this calculation. And then TM65 assumes the rest to be steel, so we're going to add 5% more steel in here and carry that math across, which gives us 148.5 to add to our total, which now brings us to 5,318.9. Let me slide this up to make a little room. You would need to then add in the embodied carbon results for any materials or components that are replaced in the product, which in TM65 estimates as 10%. So let's add that in, and we're going to add in 532, and now our total, and we're just going to drop the decimal points now. So our total is 5851. And then you multiply by the scale-up factor, which for heat pumps is 1.6. And so that brings us to 9361. And then there's an additional buffer factor of 1.3, which will bring our total to 12,170. And then there's a calculation for refrigerant leakage that takes into account the refrigerant charge, annual leakage, lifetime of the product, and some other factors, which in this example gives us 45,310. And when we total all this together, we get 57,479 kilograms of CO2. Let's scoot this up one more time. So what do we do with this number? This number allows us to compare two pieces of equipment. For instance, if two heat pumps have similar operational costs, but one has significantly lower embodied carbon, we can now factor that into our decision-making process. So this makes TM65 useful while manufacturers are trying to figure out how to do EPDs. Let's bring everything back on screen now. I think that manufacturers are going to be working through EPDs for a little while. TM65 reports help fill in that gap, giving us a way to evaluate the environmental impact of the equipment. I think we'll see more TM65 reports on complex HVAC products in the future while everyone's trying to figure out EPDs. So that's it for today's video. I hope this gave you a basic understanding of TM65. If you have any questions or topics you'd like us to cover, just leave a comment below. Don't forget to like and subscribe to our YouTube channel. Thanks for watching, and I'll see you next week.